In this video, we're going to use ratios and proportions to figure out how many grams of sugar and then calories are contained in this bag, 1,000 milliliters of D5W. There are a few things to note in this example. First, we're given an abbreviation here at the top that we're going to see starting in a couple weeks, but I want you to be aware of this. This Q6H means every 6 hours. You will also see it as Q4H for every 4 hours, Q8H every 8 hours, and so forth. It's just telling you how often you would be, in this case, giving this 1,000 milliliters of D5W. So you would repeat this, give this D5W every 6 hours, which tells us, actually, if you're doing it every 6 hours, 24 hours divided by 6, you would be giving this 4 times a day. So these are just little things we want to start to pick up on as we approach the dosage area of the course. So first, let's answer this question. How many grams of sugar will Sue consume every dose? So this is in one instance when she receives 1,000 mLs of D5W. You might be reading this, and if you aren't familiar with the common IV fluids and the ratios, this is something you need to become aware of very quickly, because it's something we're going to see consistently from here on out. D5W, even though that's not explicitly telling you a ratio, this 5 is telling you the number of grams of sugar. D represents dextrose. It is a 5% dextrose solution in water. And this number in the middle here, D5, is telling us the number of grams, 5 grams, for every 100 mLs. That is the concentration of this solution, D5W. There's also D10W, D2.5W, and the number there in the middle is telling you the number of grams out of 100 milliliters. So that is something you'll need to pick up on. But in this example, Sue is not receiving 100 mLs. If she was, we would be done, because then in this bag, if we had 100 mLs, the total number of grams of sugar are 5. The total number of mLs that Sue is actually receiving is 1,000. So we have this ratio here. We know the concentration is 5 grams per 100 mLs, but Sue is receiving 1,000 mLs, which we see is a factor of 10. So the mLs is increasing by a factor of 10, which, if we know this ratio, these two ratios are equivalent, the numerator also has to increase by that factor of 10. So 5 times 10 gives us 50. There are 50 grams of sugar. In this case, there are 50 grams of dextrose, that's a specific type of sugar, in this 1,000 mLs. You could have also solved this by cross-multiplying, or if you wanted to look at that invariant nature here, look at 5 divided by 100. All of these techniques that we saw in this module could be used here, but the solution is 50 grams. The next question says, how many grams of sugar will Sue consume per day? Now, this is where we have to consider that every 6 hours. We see here that just with one dose, Sue is receiving 50 grams of sugar every one dose. So I'm going to use a proportion again. You might be thinking, well, do I really need a proportion if I can just do a quick multiplication? The answer is no. You're welcome to, if you see how this problem could be solved just with a short multiplication strategy, that's fine, but you should be able to support it with ratios. And this is how we could do that. If there's 50 grams of sugar in one dose, we have to think about the number of doses that Sue is receiving. And we calculated that up above. If she's receiving this D5W every 6 hours, that means in one day she's going to be given 4 doses. And our unknown value is the number of grams of sugar. And once again, we see the doses are increasing by a factor of 4, so I'm going to use my proportional reasoning here. I'm going to reason and see that, well, this covarying factor needs to be the same for both the quantities in the denominator as it is for the numerator. So 50 times 4, so I'll have 50 times 4, that's going to give me 200. And it's 200 grams of sugar per day. And hopefully that makes sense. And it's just a very quick, if it's 50 per each bag, and this is happening 4 times, it's just 50 plus 50 plus 50 plus 50 for 200 grams of sugar. And finally, if each gram of sugar contains 4 calories, how many calories will Sue consume each day? Well, this is, first of all, we have to use what we just learned in the first 2 parts. But this first sentence here, if each gram of sugar contains 4 calories, they're giving us a ratio that we need here. We're told that 1 gram of sugar and 4 calories go together. There is 1 gram of sugar for each 4 calories, or 1 gram of sugar contains 4 calories, or it takes your body that amount of energy to eliminate 1 gram of sugar. But we know that Sue did not receive 1 gram of sugar. If she received 1 gram of sugar in the day, then we would have our answer, it would just be 4. But Sue received 200 grams of sugar. Through all of these fluids, that is a total of 200 grams. We don't know how many calories that is. So once again, I see that Sue, the number of sugar here, the grams of sugar, is increasing by a factor of 200, which means the same thing needs to hold for the calories. So we'll get 4 times 200, we get 800. 800 calories total in this entire dose here of 1,000 mLs 4 times a day. Again, I used, in every single example here, I did not use cross multiplication. I used the covariant factor here, looking at what the mLs increased by, looking at what the doses increased by, and then looking at what the grams of sugar increased by, and used that same factor to find the unknown quantity that I was looking for. If you were to use cross multiplication, you would arrive at the same solutions as I did.